All right, let's go ahead and begin. Short circuits in your flow. If you have a high forward flow velocity in some areas, it decreases detention time in those areas. It can also be caused by turbulence and even dispersal of influent flow across the entire tank cross section promotes even flow velocity in all sections of the tank. Weir overflow rate. Proper weir overflow rate is necessary to prevent high velocities at discharge. Remember what I said about like the thumb over the hose nozzle? Kind of like that. And it's generally 10,000 to 20,000 gallons per day per foot of weir. Calculations based on flow and length of the weir and is expressed as gallons per day per square foot as indicated in this formula below, where we have the flow rate in gallons per day over the length of the weir, or divided by the length of the weir. And the length of a circular weir is pi times the weir diameter. This math is much simpler than the last one because you don't have to find the volume first. All right, so let's go ahead and bring that up so we can run a problem over that. Let's walk through a practice problem where the flow rate is 3.5 million gallons in a circular clarifier with a weir of 75 feet. We would calculate the length of the weir for a circular one with 3.5 times 75 to get 325.5. When we divide that by 3,500,000, or we divide the 3,500,000 by 235.5, resulting in 14,861.99. And again, select the closest answer in the study guide. Because they used 3.1416 in the answer key equation without explaining why they expanded the pi, even though they only had 3.14 in the equation. So, once again, another example of select the closest answer. And let's head down to surface loading rates. Surface loading rates or surface settling rates, those two are interchangeable, directly relates to solids or solid removal efficiency. Because surface loading rates is what everything floats to the surface, and surface settling rates is everything that falls down. And generally between 300 and 1,200 gallons per tank surface area. So calculations based on flow and liquid surface area. And again, this is just another easy division. You get your flow rate and divide it by the area. So if we were to run a quick problem where we compute the loading rate when the flow into a rectangular clarifier is 40 feet wide by 110 feet long by 12 deep. I don't know why they included that. That 12 deep is not needed. That's for volume. We only need the length and width. By 5 million gallons per day. And it looks like I already did this one up. All right. Let's try a practice problem to find the surface loading rate when the flow into the rectangular clarifier that is 40 feet wide, 110 feet long, and 12 feet deep. And the flow rate is 5 million gallons per day. We can find the area first by multiplying 40 by 110 to get 4,400 or 4,400. Ignore the depth completely when finding area. It's not needed. That's only for volume. So we just divide the flow of 5 million gallons per day by the area of 4,400 to get 1,136.36 repeating, I believe. Solids loading. The amount of solids which may be removed for each unit of clarifier surface area. Typical solids loading. Primary clarifiers, generally not a consideration for this. Secondary clarifiers, 12 to 30 pounds per day. Dissolved aeration flotation is 5 to 40 pounds per day. And sludge thickening is 5 to 20 pounds per day. And it's going to run us through another formula. It is flow in millions gallons per day times conc times 8.34 pounds. Indicators of clarifier operating problems. Floating sludge, or quote unquote bulking. Black odorous septic wastewater entering the clarifier. Or black water leaving the clarifier. If there's scum in the clarifier effluent, sludge that's hard to remove from the hopper, low sludge solids, and miscellaneous problems could be surging flow, slime growth, excessive corrosion. Mechanical problems you can run into is chain drive issues, your seals not working properly, or bearings in your pumps or in your weirs that are rotating. Like, if you're having issues, it's best to look at everything, especially if the thing comes down to shut down the clarifier and you get a chance to take a look at everything. You might as well go through all of this and swap out your seals, grease up your bearings, grease up your chain. You do all that while it's already down. Flotation. General wastewater always contains some suspended solids that have neutral buoyancy and they neither settle nor float. And that's why we introduce a polymer, because it helps collect that and sink it down. Particles can be flocculated with air or chemical coagulants and either settle if heavy or float if using small air bubbles. Vacuum flotation. This isn't something I have experience with, but aerated to saturation with dissolved air, flows into a vacuum chamber which pulls out the air in the form of small bubbles. Pressure flotation. Aerated pressure and pressure released dissolves air released in the form of small bubbles. Specialized processes. Combined sedimentation digestion units. Sedimentation occurs in upper units. Solids or sludge fall to lower unit for digestion. Usually for septic tanks are usually for individual homes or small contributing populations. Operations similar to combined sedimentation and digestion units. The solids must be removed periodically and disposed of at a waste treatment plant or septage processing facility or land applied. Liquid effluent usually disposed of underground by leaching through the soil. So I know in a lot of old towns, especially out of the country, they would use a leach bed. But I think that's not applicable in many places anymore. Key points. Primary treatment consists of sedimentation and flotation. Sedimentation is the removal of heavy solids and any remaining grit not previously removed, and generally takes place in clarifiers or combined sedimentation digestion units. Flotation is the removal of grease and other lighter solids which will not settle, because it all floats up to the top instead of sinking to the bottom. The most important function of a clarifier is to remove as much settleable and floatable material as possible. Detention time based on flow and tank volume is generally 2 to 3 hours. Most common factor influencing settling characteristics are temperature, detention time, short circuits, weir overflow rate, surface settling, and solids loading. Those were all those equations we went over previously. Indicators of clarifier operating problems include bulking sludge, scum in the clarifier effluent, sludge that's hard to remove from the hopper, and low sludge solids, just to name a few.